Hello and welcome students. My name is Shampa. Today we are going to study a topic in mathematics called rational numbers. In today's topic, we will learn what are rational numbers and what is the difference between rational numbers and fractions. Also, we will study the standard form of a rational number. We will study about equivalent fractions, and also we will learn to compare two rational numbers. So let's begin. So let's understand what are rational numbers. Rational numbers are integers. They are in the form of p by q, where q is not equal to 0. Let us understand what is p and q. Let's say I have a pizza and I divided the pizza into 8 equal parts. We have 8 equal parts of this pizza. Now in this case 8 will be the denominator. The number which is below the line, that is q. The q that we have just mentioned here. So 8 is the denominator and 8 represents the total number of equal parts in the collection, and it is called the denominator. Now if I say I took out 3 parts out of it, let's shade the 3 parts. Friends, this figure is not to scale, and I took out 3 parts out of it, so 3 will be the numerator. Numerator is always above the line and it tells us how many equal parts of the whole are taken, and denominator is below the line. It shows the number of equal parts in the collection. So if we represent it in the form of p by q, we have p as the numerator and q as the denominator. In this case, p is equal to 3 and q is equal to 8. So the rational number is 3 by 8. Now let us understand what is the difference between fractions and rational numbers. Well, there is only one difference. In case of fractions, the numerator and the denominator are whole numbers, and in case of rational numbers, the numerator and the denominator are integers. Let's take the example of 2 by 5 and 3 by 7. In this case, 2 is a whole number, 5 is also a whole number, so 2 by 5 is a fraction, and it's a rational number as well because 2 is an integer and 5 is also an integer. Same holds true for 3 by 7. But what about minus 2 by 5 and minus 7 by 12? Minus 2 is an integer, but it is not a whole number. Same goes with minus 7 by 12. Minus 7 is an integer, but it is not a whole number. So minus 2 by 5 and minus 7 by 12 are not fractions, but they are rational numbers. So all the fractions are rational numbers, but all the rational numbers are not fractions. So we can say fractions are actually a subset of rational numbers. Rational numbers cover fractions, natural numbers, whole numbers, integers, and rational numbers themselves. Here I have a simple figure that will explain the concept. We have natural numbers, and natural numbers are a subset of whole numbers because natural numbers are all the counting numbers starting from 1 to infinite, and whole numbers are all the counting numbers along with 0. Integers are all the counting numbers, 0, and the negative numbers. So natural numbers are a subset of whole numbers, and whole numbers are a subset of integers, and rational numbers are a superset of natural numbers, whole numbers, integers, and rational numbers. So does that mean that we can express natural numbers, whole numbers, and integers in the form of P by Q? Yes, why not? Let's take the example of a whole number 7. We can always express 7 in the form of P by Q, where Q is equal to 1. For the sake of simplicity, we do not mention 1 in the denominator, but it is there. We took this integer minus 6. We can represent it as minus 6 by 1. So all the natural numbers, whole numbers, and integers can be expressed in the form of rational numbers. Here is a basic question that might come to your mind. Is it possible to write 0 as a rational number? Well, yes, it is possible. Let's take the example of pizza. There's a pizza. I divided it into 8 equal parts. And I asked you to take 0 part out of it. It means I asked you to take nothing, but 0 can be represented in the form of P by Q because 0 is an integer. So we can place 0 in the numerator. So 0 by 8 is possible. But is it possible to place 0 in the denominator? Let's take the example of pizza again. There's a pizza and I divided it into 0 parts, which means I did not divide it at all. And I asked you to take 8 parts out of 0 parts. So is that possible? That's not possible. That's ridiculous. So 8 by 0 is simply not possible. And it satisfies the definition of rational numbers, that rational numbers are integers in the form of P by Q, where Q is not equal to 0. Now let us understand what is the standard form of a rational number. Let's understand it with the help of an example. Say 7 by 8. We have 7 by 8. We can break down 7 into its prime factors. We can write it in this form. 7 into 1. We can write 8 in the form of 2 into 2 into 2 into 1. So what do we see? The only common factor between 7 and 8 is 1. So if we cancel 1 from the numerator and the denominator, we are left behind with 7 by 8. So 7 by 8 is in the standard form. So a rational number is said to be in the standard form when the numerator and the denominator does not have a common factor other than 1. Let's take another example. Let's take the example of 56 by 63. Let's break the numerator into its prime factors. We can write 56 like this. I'm extremely sorry. And we can write 63 like this. So do we see a common factor? Yes, 7 is common. Divide 7 by 7, they will cancel out each other and we will be left behind with 8 by 9. So 8 and 9 has no common factor other than 1. So 8 by 9 is the standard form of the rational number. Now let's take the example of 71 by 80. 71 is a prime number, so if we break down into its factors, we will have only 2 factors, 71 and 1. 80, we can break down 80 as like this, 2 into 2 into 2 into 2 into 5. So here we see, we can write 1 here. That will not make much of a difference. So the only common factor we have is 1. And if we cancel out 1 and 1, we will be left behind with 71 by 80. So this number is in its standard form. Now let us understand equivalent fractions. Say I have a fraction 4 by 5. And now if I multiply 2 to the numerator, it will not be fair because it will change the fraction. It will change the value of the fraction. So in order to do justice to the fraction or the rational number, we will multiply the same number to the denominator. So now it will become 8 by 10. So we can say that 8 by 10 is the equivalent fraction of 4 by 5. Let's take one more example. Let's say I have 75 by 125. And now if I divide the numerator by 25, in that case, in order to do justice, I'll have to divide the denominator by 25 as well. So the new rational number we have got is 3 by 5. So 3 by 5 is the equivalent fraction of 75 by 125. Even otherwise, you can see that if we break down 75 and 125, we will get 3 by 5. We can write 75 as 25 into 3, and we can write 125 as, 25 into 5. So 25 will cancel out each other and we will be left behind with 3 by 5. So whenever we multiply or divide the same number to the numerator and the denominator, the result that we get is called an equivalent fraction. And here we are in the last section of our session. In this section, we will compare two rational numbers. Well, there are three cases. First case is when the denominators are the same. This is the easiest. And the second case is when one is a proper fraction and the other is an improper fraction. And the third case is when there are two proper fractions or two improper fractions with a different denominator. So we will discuss one after the other. So the first case is when we have two rational numbers where the denominators are the same. In this case, say we have a material and we divided it into 15 equal parts. We asked A to take out 7 parts out of it, and we asked B to take out 9 parts out of it. There is a material, we divided it into 15 equal parts, and A took out 7 parts out of it, and the same material has been divided into 15 equal parts and B took out 9 parts out of it. So definitely 9 is bigger than 7. So 9 by 15 is greater than 7 by 15. So whenever the denominators are the same, we compare the numerators, and the rational number with a bigger numerator is always the greater rational number. Now let's take the example of minus 2 by 3 and minus 1 by 3. In this case, denominators are the same. Let's compare the numerators. In this case, minus 1 is greater than minus 2. We know the rule of integers. So minus 1 by 3 is greater than minus 2 by 3. Let's move on to the second case. Well, the second case is when there is a proper fraction and when there is an improper fraction. Always remember, we don't need to think much about it. Whenever there is a case where there is a proper fraction and an improper fraction, the improper fraction is always going to be greater. In case of positive numbers, in case of negative numbers, the sides are going to change. We will discuss that. We will come to that topic as well. So in this case, 26 by 19 is greater than 13 by 21. We know, students, that a proper fraction, value of a proper fraction is always less than 1, and an improper fraction is more than 1. This is 19 by 26. Now there is one more case which I did not mention that we are going to discuss, but we should discuss it. It's important. Say I have two rational numbers and they are both proper fractions. The numerators are the same, but the denominators are different. In this case, which one is going to be greater? Now the number with a smaller denominator is always going to be greater. Don't believe me, I'm going to prove it. Say I have a material and I divided it into 3 equal parts. And the same material I divided into 5 equal parts. Now if I take out 2 parts out of 3 parts, this much part has been extracted. And here if I take out 2 parts out of 5 parts, this much has been extracted. So it's clear that 2 by 3 and 2 by 5, between 2 by 3 and 2 by 5, the 2/3 part is greater than 2/5 part. So whenever the numerators are the same, the number with a lesser denominator is always greater. Here is one more case. How are we going to compare these two rational numbers? We have minus 7 by 9 in the LHS and 7 by 6 in the RHS. Here also, you don't have to think much because one is a negative rational number and other one is a positive rational number, and positive numbers are greater than negative numbers, so definitely the number with a positive sign is greater. Now let's discuss the last segment, that is when the bases are different. There are two ways to do it. We will do it one after the other. Let's take 7 by 15 and 4 by 9. In this case, both are proper fractions. Numerators are different and the denominators are also different. Well, the first method is on the, here we write the LHS and RHS. The first method is just cross multiply. Multiply the numerator of the left hand side to the denominator of the right hand side. That is 7 into 9, and take the numerator of the right hand side, multiply it with the denominator of the left hand side. That is 4 into 15. 7 into 9 is 63 and 4 into 15 is 60. 63 is greater than 60. Therefore, 7 by 15 is greater than 4 by 9. Now let's solve the same problem but with a different method. That is the LCM method. So the rational numbers that we have are 7 by 15 and 4 by 9. First step is find the LCM of 15 and 9. We can find out the LCM by the prime factorization method. Let me show it to you quickly. Let's do it. Here we go. So we have the LCM equal to 45. Now we will move on to the second step. In the second step, multiply the denominator with a number so that we get the denominator equal to the LCM. So we will have to multiply it with 3, and because we multiplied the denominator with 3, we will have to multiply the numerator as well with 3. Repeat the same step for the next rational number. What are we going to multiply to 9 to make it 45? We will multiply it by 5, and we will repeat the process for the numerator. So we have got 21 by 45, and we have got 20 by 45. So clearly 21 by 45 is greater than 20 by 45, which means 7 by 15 is greater than 4 by 9. Now that's all we have for this session. See you in my next session, where we are going to do some operations on rational numbers, and we will discuss some basic properties of rational numbers. Till then, please take care of yourself and have a good day.